Let me tell you where most people go wrong with Python. They start with a general programming course. Loops, classes, object-oriented design, recursion. 3 weeks in, they've written a program that plays tic-tac-toe, and they still cannot open a CSV file and answer a business question. That's not their fault. They were taught Python for software engineers. You need Python for data analysts, and it is a genuinely different subject. Here's the honest truth. You need maybe 15% of the Python language. You need Pandas deeply. And you need to know when Python is the wrong tool, which most tutorials never mention. So this is the deep dive. From absolutely nothing to the stuff that separates a real analyst from someone who copies code off the internet. Setup done properly. The small slice of core Python you actually use. Pandas in depth. Cleaning messy data. Grouping and joining. Visualization. Automation. And how AI fits in without rotting your skills. This is long. Use the chapters. Let's go. First, let's settle when you should even reach for Python. Because reaching for it at the wrong moment is a real mistake, and it makes you slower, not faster. Excel wins when the data fits on screen, when a human needs to open it and change a number, when you need an answer in 20 minutes. SQL wins when the data lives in a database, which is almost always, and when you're filtering and aggregating. Honestly, if SQL can do it, let SQL do it. It's faster and closer to the source. Python wins in 4 situations. 1. The task repeats. You do it weekly, forever. 2. The cleaning is too complex for formulas. Messy text, inconsistent dates, nested data. 3. You need statistics or modeling beyond what a spreadsheet gives you. And 4. You need to connect things. Pull from an API, transform it, push it to a database, email a report. That's automation, and it's where Python genuinely shines. So the practical rule. Pull with SQL, explore in Python, present in Excel or a BI tool. Automate with Python when the task repeats. Setup. And I'm going to save you a week of pain here, because this is where a lot of people quit before they start. Do not install plain Python from the website. Install Anaconda, or its lighter version, Miniconda. It comes with Pandas, NumPy, matplotlib, and Jupyter already included, and it manages environments for you. Then, environments. And this sounds boring, but it will save you eventually. An environment is an isolated box of packages for one project. Why bother? Because project A needs Pandas version 1, project B needs version 2, and without environments they fight and something breaks silently. One command. Conda create -n, then your project name. Then conda activate. Done. Where do you actually write code? Jupyter notebooks for exploration. You run one cell at a time and see the result immediately, which is exactly how analysis actually works. And VS Code for anything you run more than once or share. Rough rule. Exploring, notebook. Building something reusable, a .py file in VS Code. Now the core Python you actually need. And it is a much shorter list than any course will tell you. Variables and the 4 data types. Strings for text, integers and floats for numbers, booleans for true and false. Then the 2 containers that matter. Lists written with square brackets, and ordered collection you can change. And dictionaries with curly braces, which are key value pairs. Name, Asha, age, 30. Dictionaries matter more than people expect, because almost every API response you'll ever touch is a dictionary. Then if statements for logic, for loops for repetition, and functions so you write something once and reuse it. Here's what you can genuinely skip at the start. Classes, inheritance, decorators, generators, async, all useful in software engineering, almost never needed in day-to-day analysis. And here's the one piece of core Python that pays for itself immediately. List comprehensions. One line that builds a list from another list. Once it clicks, you'll use it constantly. Pandas. This is 90% of the job. So let's build it properly. 2 objects. A series is a single column. It has values and an index. A data frame is a whole table, rows and columns. Think of it as a spreadsheet you control with code. Getting data in. Read CSV for a comma-separated file, read Excel for a spreadsheet, read SQL if you're pulling from a database. And Pandas can read straight from a URL, which is great for public data. Now the first 4 commands you run on any new dataset, every single time. .head to see the first 5 rows, .shape which gives you rows and columns as a pair, .info which shows column names, data types and how many non-null values there are, and .describe for summary statistics on the numeric columns. Those 4 take about 10 seconds and they will tell you more about your data than an hour of guessing, especially .info. Because the most common bug in Pandas is a column you think is a number and Pandas thinks is text. Selecting data. And this is where beginners get genuinely confused. So let me make it clean. To get one column, use square brackets with the column name in quotes. That returns a series. For multiple columns, pass a list inside the brackets. So you end up with double square brackets, which looks strange the first time. Then filtering rows. You write a condition inside square brackets. DataFrame where the revenue column is greater than 1,000. And here's the rule people trip on. For multiple conditions, use the ampersand for and the pipe for or, not the words. And you must wrap each condition in its own round brackets. Miss those brackets and you get a cryptic error that tells you nothing useful. Then loc and iloc. Loc uses labels. Row named this, column named that. Iloc uses integer positions. Row 3, column 2. My honest advice, use loc almost always. Position-based selection breaks the moment someone reorders your columns. And use query for readable filters. DataFrame.query revenue greater than 1,000 in plain text. Cleaning. This is where you'll actually spend your time. So let's be thorough. Missing values first. IsNull.sum gives you a count of missing values per column. Run that early every time. Now, what do you do about them? You have 3 options and choosing well matters. Drop the rows with dropna. Fine if it's a small percentage and the missingness is random. Dangerous otherwise because you might be systematically deleting a particular kind of customer. Fill them with fillna, with 0 or the mean or the median. Median is usually safer for skewed data. Or forward fill for time series, which carries the last known value forward. Or, and this is the underrated option, leave them. Sometimes missing is information. A missing delivery date might mean the order was never delivered. That's a finding, not a gap. And whatever you choose, write down why. Because in 3 months, someone, possibly you, will ask why there are zeros in that column. And I don't remember is not a good answer. Duplicates and types. Duplicated.sum tells you how many exact duplicate rows you have. Drop duplicates removes them. But be careful. You can pass a subset of columns, saying 2 rows are duplicates if the customer ID and the date match, even if other columns differ. That's usually what you actually want. Then data types, and this causes more silent bugs than anything else. A number stored as text will not sum. It will concatenate or throw an error. To convert, use as type, or better, to numeric with errors equals coerce. That turns anything unconvertible into a missing value instead of crashing, which lets you find the bad rows and look at them. Dates, to date time. And if your dates are in day, month, year format, tell Pandas explicitly because it may assume American month, day, year and silently mangle your data. Then text. The .str accessor gives you string methods on a whole column at once. str.strip for white space, str.lower for consistent casing, str.replace and str.contains for filtering. Groupby. This is the single most powerful thing in Pandas, and it's the direct equivalent of groupby in SQL. The pattern is split, apply, combine. Split the data into groups. Apply a calculation to each group. Combine the results back into one table. Group by region, then sum revenue. 3 words and you've collapsed 100,000 rows into a summary. Then ag, which is where it gets genuinely powerful. You can apply different functions to different columns in one call. Sum the revenue, count the orders, and take the average order value all at once, per region. And you can name the output columns while you do it, which keeps things readable. One thing that catches everyone. After a group by, your grouping column becomes the index, not a normal column. So chain reset index on the end, and you get a clean normal data frame back. Then transform, which is the advanced one worth knowing. It gives you a group level calculation, but keeps every original row. That's how you add a column showing each sale as a percentage of its region's total. Combining data. 2 operations. Concat stacks tables. 12 monthly CSVs into one. It's just gluing them together, usually vertically. Merge joins them on a matching column. And if you know SQL joins, this is exactly the same thing. Same 4 types. Inner, keeping only matches. Left, keeping everything from the left table. Right and outer, keeping everything. The syntax is merge, then the 2 frames, then on equals your key column, then how equals left or inner. And here's the trap that'll get you. Exactly like it does in SQL. Fan out. If your right-hand table has multiple rows per key, your row count multiplies after the join. Same discipline applies. Print the shape before the merge, print it after. If the number went up unexpectedly, stop and find out why. Also use the indicator argument. Set it to true and Pandas adds a column telling you whether each row matched both sides or only one. That's the fastest way to debug a join that's quietly losing data. Visualization. And there are 3 libraries, which confuses people. So let me be direct about when to use each. Matplotlib is the foundation. Everything else is built on it. It's verbose, but it gives you total control. You'll use it for final tweaks. Seaborn sits on top and is much nicer for statistical plots. Distributions, relationships, categorical comparisons. Fewer lines for a better looking result. And Plotly for interactive charts. Hover tooltips, zoom, and it embeds in a web page. Here's the practical shortcut. Pandas has plotting built in. Just call .plot on a data frame and you get a chart instantly. That's what you use while exploring. Nobody else sees it. It doesn't need to be pretty. It needs to be fast. Then when it's going in front of someone, switch to seaborn and add labels. And here is the thing that separates an analyst from a beginner. Always label your axes. Always add a title that states the finding, not the variable. Revenue grew 40% in the South, not revenue by region. Let me give you the exploratory workflow I'd actually run on a fresh dataset. Step 1. Shape and info. How big is it and what types did Pandas guess? Step 2 is null.sum. Where's the missing data and is there a pattern to it? Step 3. Describe. Look at the min and max especially. That's where you spot impossible values. A negative age, a price of 10 million. Step 4. Value counts on your categorical columns. This catches inconsistent categories instantly. North, north, and north with a trailing space are 3 different values to Pandas and 1 thing to a human. Step 5. Histograms of your numeric columns. You're looking at shape and outliers. Step 6. A correlation heat map if you're heading toward modeling. And step 7. The one people skip. Sort by your key metric and just read the top 10 and bottom 10 rows. Actually look at them. That 5 minutes finds data quality problems that no summary statistic will ever show you. Now let's talk about performance. Because this is where analysts write code that works on 1,000 rows and dies on 1,000,000. The rule is avoid loops. Pandas is built on NumPy, which does operations on whole arrays at once in optimized C code. That's called vectorization. So if you want to add tags to a price column, don't write a for loop over the rows. Just write price times 1.18 on the whole column. It's one line and it's often 100 times faster. And please never use iter rows. It's the slowest thing in Pandas and there is almost always a better way. What about apply? Apply is a middle ground. It's more flexible than vectorization, but it's still a loop underneath, just a tidier one. Use it when there's no vectorized alternative. Then np.where for simple conditional logic. Give it a condition, a value if true, a value if false. It's the vectorized version of an if statement. And np.select when you have several conditions. That's the clean replacement for a chain of nested ifs. Time series. Because so much analyst work is about dates, and Pandas is genuinely excellent at this once you know 2 things. First, set your date column as the index. To date time, then set index. Now Pandas knows this is a time series and a lot of magic becomes available. You can slice by string. Give it just a year and get that whole year. Give it a year and month and get that month. Second, resample. This changes the frequency of your data. You have daily sales, you want monthly. Resample, M for month, then sum. One line. And you can go the other way too, upsampling and filling gaps. Then the ones you'll use constantly. Rolling for moving averages. Rolling 7, then mean, gives you a 7-day rolling average, which smooths out weekly noise and makes trends actually visible. And shift, which moves data up or down by a period. That's how you calculate growth. Take this month, divide by shift 1, which is last month, and you've got month-over-month change in one expression. Automation. This is where Python stops being an analysis tool and starts genuinely giving you time back. Here's the pattern. Take something you do every week by hand. Download a file, clean it, make a summary, email it. Write it once as a script. Then schedule it. The pieces you need. Requests for pulling data from an API, Pandas for the transformation, to Excel or to CSV for writing the output. And for scheduling, cron on Mac or Linux, task scheduler on Windows, or GitHub Actions if you want it running in the cloud for free. 2 habits that make automation actually survive contact with reality. Logging, not printing. Use the logging module so you have a record of what happened at 3 in the morning when it broke. And error handling. Wrap the risky parts in try and accept so one bad row doesn't kill the whole run silently. And here's the honest measure of whether it's worth automating. If a task takes 30 minutes and you do it weekly, that's 26 hours a year. Spending 4 hours to automate it is obviously worth it. AI and Python. And this genuinely changed the job. So let me be specific about how to use it well. 4 things it's excellent at. 1. Writing the boilerplate. Describe the transformation you want in plain English, get working Pandas code. This is a real speed up. 2. Explaining code you inherited. You open a colleague's notebook and there's a chain of 8 Pandas operations. Paste it, ask what it does. Faster than any documentation. 3. Debugging. Paste the error message and the code. It usually spots it instantly and explains why. 4. Converting between languages. I have the SQL, give me the Pandas equivalent, or the reverse. Now the danger, and it's specific. AI does not know your data. It will write beautiful code that runs perfectly and produces a wrong number because it assumed your date column was clean or that your join was 1-to-1. So the discipline is simple. Run it on a small sample first. Check the shape before and after. And if you can't explain what the code does line by line, don't put it in production. The mistakes that actually cause damage. I've made most of these. 1. The setting with copy warning. You filter a data frame, then try to change a value. And Pandas warns you that it's unsure whether you're editing the original or a copy. Do not ignore this. Use .copy when you slice or use lock to assign. Otherwise, your edit may silently do nothing. 2. Chained indexing. 2 sets of square brackets in a row when you're assigning. Same problem. Use lock. 3. Not checking shape after a merge. Fan out will quietly triple your numbers. 4. Hard-coded file paths that only exist on your laptop. Use relative paths or a config at the top. 5. A notebook where cells have been run out of order. It works on your screen and folds for everyone else. Restart and run all before you share anything. 6. No requirements file. Nobody can reproduce your work. And 7. Analysis buried in a notebook with no explanation. If there's no markdown saying what you did and why, it's not analysis. It's just code. Let me show you what a proper project structure looks like, because this is what separates a professional from a hobbyist. A folder with 4 things. Data, containing raw and processed subfolders, and raw is sacred. You never edit raw, ever. Notebooks for exploration, source for reusable functions you've pulled out of your notebooks, and a readme explaining what this does and how to run it. Then a requirements.txt listing your packages so someone else can recreate your environment with one command. And use Git, even alone, even for small things. Because being able to see what you changed last Tuesday and undo it is worth the 20 minutes it takes to learn 3 commands. Here's the mindset shift that matters. Your notebook is a workspace, not a deliverable. The deliverable is a clear finding and code someone else could run. When you find yourself copying the same cleaning function into a 4th notebook, that's the signal. Pull it into a source file and import it. That's the moment you stop scripting and start building. So how do you actually learn all this? Here's the order that works. Week 1 and 2, set up and core Python, just the 15%. Lists, dictionaries, loops, functions, comprehensions. Week 3 and 4, Pandas basics. Loading, selecting, filtering. Do this on real data, not tutorial data. Week 5, cleaning. Missing values, types, duplicates, text. Week 6, group by and merging. This is the analytical core. Week 7, visualization. Matplotlib basics, then seaborn. Week 8, time series and performance. Then ongoing, automation and project structure. Total around 2 months at 10 hours a week to genuinely useful. And your portfolio move? Find a messy public data set. Build a notebook that goes from raw file through cleaning to 3 clear findings. Then, and this is the part that matters, pull your cleaning steps into a reusable module and write a readme. That structure signals more than any certificate. Quick recap. You need 15% of Python and Pandas deeply. Know when SQL is the better tool. Cleaning is the job. Group by is the core. Vectorise, don't loop. Check your shape after every merge. and AI writes the code, but you own the number. If this helped, subscribe and tell me in the comments which part of Pandas took you longest to understand. See you in the next one.